Welcome to Unit 1 on Critical Thinking in Statistics. Section 1.1 is on Statistics and Critical Thinking. Now, before we could really delve into all the topics involving statistics, we do need to start with a couple of definitions. I know, not exactly the most fun way to start a topic, but the definitions do help us all basically provide a way for us to talk like statisticians and allow us to better understand what we're talking about. So to start off with data. Data is a collection of observations including measurements and survey response. And a singular piece of data is called a datum. Statistics is the science of planning studies and experiments, which includes obtaining data and organizing, summarizing, presenting, analyzing, and interpreting the data to draw conclusions. The population is the complete collection of all measurements. It's typically used to make inferences. A census is a collection of data from every member of the population. And a sample is a subcollection or a subset, or just merely a small part of the members from the population. So, based upon that, we have our example 1 here. In a journal article, Residential Carbon Monoxide Detector Failure Rates in the United States by Ryan and Arnold in the American Journal of Public Health, Volume 1, 10.1, number 10, it was stated that there are 38 million carbon monoxide detectors installed in the United States. When 30 of them were randomly selected and tested, it was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. What are the population and sample in this scenario? So for something like this, we need to define that population and sample. So population here is going to be our 38 million carbon monoxide detectors installed in the United States. So 38 million carbon monoxide detectors. And if I could spell that, that would be helpful, wouldn't it? So 38 million carbon monoxide detectors installed in the United States. And the sample would be the 30 that were randomly selected. So 30 randomly selected. Carbon monoxide detectors. Alright, and so from that, we have our statistical thinking flowchart. And the way that this is noted here is the context. We first need the context of our statistical thinking, meaning what does the data represent? What is the goal of the study? We need the source of the data. So is the source of the data with a special interest? So there's pressure to obtain results that are favorable? Or is it something that was not collected from a special source or someone with a vested interest? The third one is the sampling method. Were the data collected in a way that's unbiased? Or were the data collected in a way that is biased? And using those various forms of bias in sampling. Next, in the analyze section, we would graph the data, and we have various tools in order to do that, and then explore the data. And the exploration of the data includes calculations such as any outliers, the important statistics to summarize the data, such as mean, standard deviation, a 5-number summary, that type of thing. How's the data distributed, aka the shape? Are there any missing data? How many selected subjects refuse to respond or create some type of non-response bias? And then apply statistical methods, meaning confidence intervals, hypothesis tests, methods such as that. And then, of course, let's face it, the most accurate results are indeed obtained by technology. And then the last part here is to conclude, meaning to conclude with the significance of the test. Is there practical significance or statistical significance, and what on earth do either of those mean? Well, let's look through all of these parts. So the context in a statistical inference, that's determined by the relationship between the variables. Meaning, is there any relationship between the variables? So, is there a relationship? Although if you're running your own study, that's something that you would be specifically stating yourself. The second is the source of the data. So this is used to determine bias with regards to who sponsors or runs the statistical inferences, being a company or an individual. Company or individual. But that's most based upon whatever's happening with that data set. And then some journals require resources to be reported, meaning how was that data collected? The sampling method, this is where a sound sampling method is essential for the results in a statistical study. The best methods use some form of randomization, and we'll discuss what that means later on. It's generally bad, though, to use a voluntary response or self-selected sample. That's where the response choose to be included, but despite that fact, it's still a very, very common form of a study, despite the fact that it is not exactly a good way to be conducting the data. And the methods that cause a voluntary response include internet polls, such as on Twitter or on some random website, a mail-in poll, meaning something that you get mailed to your home and you have to fill it out, or a telephone call-in poll. That could be that someone calls you and asks you to respond, or it could be something such as you mailed something or sent an email saying, hey, call this number to respond to a poll, that type of thing. The next is the analyze. So that's where we are considering the context, source, and sampling method so we can analyze the data. and try to determine what on earth any of it means. And it begins with the appropriate graphs and explorations of the data. Next, then, we would apply the statistical methods. So, easiest is to use technology, although depending on what form of technology that you're using, sometimes the actual programming of it can be, unfortunately, sometimes more of a hassle than the actual computation itself. It requires some common sense and paying careful attention to sound statistical methods. And it usually refers to the inference step of a statistical study. And it also looks at basically what we're trying to find with regards to any confidence intervals, hypothesis tests, what actually answers our question. The conclusion, this specifically is separated between statistical and practical significance. Statistical significance is where the result is unlikely to occur due to chance. So a common criterion is to use a likelihood of the event occurring by chance of 5%. It can be, though, as high as 10% or as low as 1%. That depends on the particular study. But the most common one is indeed 5%. Such as, for example, if 98 girls and 100 random births is statistically significant, that's because, having 98 out of 100, that's a pretty good amount, right? 98%. That's not by some random chance. But 52 girls and 100 random births, that is not really statistically significant, right? Because that is something that could potentially be random chance, since 52 is just slightly greater than 50. If we want to have a base number to compare that to. The practical significance, on the other hand, is some treatment or finding is effective, but common sense suggests that the treatment or finding does not make enough of a difference to justify its use. Basically meaning that it's not practical. So, for example, would it be practical for a mother to attempt to get a daughter if 98 girls and 100 random births occurred? That might be potentially something that you could look into. But if it's something like 52 girls and 100 random births, again, that's very close to 50, with such a minor difference. Is that particularly worth it or not? Something like that is probably not really practical. So, for my next example here, the USA Today posted this question on the electronic edition of their newspaper: have you ever been bitten by an animal? Internet users who saw this question then decided themselves whether to respond. Among the 2,361 responses, 65% said yes and 35% said no. And we want to know, is this a voluntary response poll? So essentially that's a yes. The internet users chose to respond. So, internet users chose to respond. And then based upon that, that's why that would be a voluntary response poll. And then finally, Procare Industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender that they desired. In the absence of any evidence of its effectiveness, the product was banned by the Food and Drug Administration, or FDA, as a gross deception of the consumer. But suppose that the product was tested with 10,000 couples who wanted to have baby girls, and the results consist of 5,200 baby girls born in the 10,000 births. The likelihood of this happening by chance, though, is 0.03 of a percent. Identify its statistical significance versus practical significance. Well, it is statistically significant. Statistically, be helpful if I could spell that correctly, wouldn't it? Statistically significant. Right, since that likelihood of it happening by chance is 0.03 of a percent. So, by chance, is that 0.03 of a percent. But is it practically significant? The answer to that is going to be a no. Not practically significant. That being due to the fact that this made a 52 percentage. Baby girls being born. And what that means then is that 52% is very close to 50%. And let's face it, not too many couples, if any, are going to see that as really something to even look into, since it's so close together. Some pitfalls, though, when analyzing data. We can make a misleading conclusion. That's where the statement of conclusions are clear to those with no knowledge of statistics. And we want that to actually then make a conclusion that's sound and justifiable. Correlation does not imply causation. The sample data reported instead of measured, that's where it's better to take measurements rather than asking for a measurement. Loaded questions, that's where the questions are loaded or intentionally worded to elicit a desired response. The order of questions, that's where they can be loaded unintentionally or intentionally, depending, by the order of items, or order of questions, or order of answer choices. Now response, that's where it's the refusal to respond or unavailable to respond. And by percentages, that's where we could cite misleading or unclear percentages, even giving percentages greater than 100%. Thank you.